What are you doing? All right. So so on here, you'll be doing parts of your FRQ for due nouns Tuesday, Wednesday, Thursday, and Friday of next week. Okay. Moving on. Part 1, part 2, part 3 of our 1A4. We will be working on today, Tuesday, and Wednesday is the goal to be done with all 3 parts. Okay. And then we have part 5 next week. Okay. We're supposed to be testing by the 12th for 1A. Okay. We are supposed to be testing by the 12th. And no. So I just want to give you all the heads up that we are going to be working, getting through this. It's a lot of content, and technically we're supposed to be done with a lot of it by mid-April so that we can prep for the test. So time has to happen. All right. But 1A4, polynomial functions and rates of change. We talked about polynomial functions last year in Algebra 2, as far as how many x values they have, how they increase, decrease, whether it's odd, even, all of that. So that's not really our focus here. We're going to address it, but we have to have that background knowledge to understand what we're doing, right? We're not going to reteach those things necessarily. So for our 1A for part 1, we have polynomial functions and rates of change. So we're going to focus on just the characteristics of polynomial functions and what they are and what they mean. So the first polynomial function you ever work with is a linear function, right? A linear function is a first degree polynomial, right? Then the second polynomial function you work with is a quadratic. A quadratic is a second degree polynomial, right? After that is our cubic, and then after that is quartic, and then from then we just say polynomials, right? There are names for up to 10, but there's no point of knowing those names. Does that make why? I mean, I know them, but there's no point for you, okay? But polynomials are the sum of monomials, right? And that just means I'm adding or subtracting numbers and variables with powers. Make sense? Okay. This is the standard form of a polynomial, and this is just saying that your powers are in order from greatest to least. Okay. And then the degree. Your degree is your highest power, right? Your leading coefficient is the number with the highest power. Okay. A constant of a polynomial is also a polynomial with degree 0. So like if I just had a number, technically that's a polynomial. It's just a degree of 0 because anything to the 0 power is 1, and anything times 1 is itself. So that's what that would be. Okay. Turning points. A turning point is where the graph of a function changes direction. So that means I'm going from increasing to decreasing, or vice versa. So turning point, I'm increasing. Like, oh no, now I am decreasing. So this is a turning point. Make sense? Vice versa, I'm decreasing. Oh no, I turn and now I am increasing. Those are your turning points. When we talked about quadratics, we called that our what? What was that called of the quadratic? Our vertex. That was our vertex, right? But now you're going to have multiples of them. So we call them turning points. Okay. The direction of the graph of the function you move to from the left to the right and away from the origin is commonly called the end behavior. Okay. What is your function doing on the ends? Do y'all remember our dancing man? Remember the dancing man? We talked about him last year. Okay. If we don't remember, don't say that. So a little stick guy, he was on the board and we had to do this, but to decide whether it was a positive. Yeah, I know. I remember the little dancing little man that y'all didn't appreciate my man I created for you. But so remember, if we're talking about whether it's positive or negative, right? If it's a positive polynomial, that means I'm going to end positively, right? But if I'm even, I also am going to start positive. But if I'm negative, I'm going to start the opposite. You remember that? Those rules. So those are things that you should have in your brain. Okay. All right. So we're here. Maximum and minima for any function, there exists an interval from A to C that contains B so that X cannot equal B. So some value in between, right? Then F has a local maximum at B. Okay, a local maximum means that it is not necessarily my highest point, but it's a point where it goes from increasing to decreasing. So when I'm talking about local maximum, I'm looking, when do you go from increasing to decreasing? Okay, that's what I'm looking for. So when we look at what we call that, it's called a relative, or some books would call it a local maximum. So looking at our graph that we have here, how many relative maximum or local maximums do we have?
1 by 2.
Why do we have two?
Because it's going up.
Exactly. We have 2 points where we increase, then decrease. And here we increase and we also decrease. So these are my maximum. Easy enough? Okay. So therefore, a local minimum is when you're going to decrease and then increase on some interval, right? So on that interval, we call that a relative, again, or local minimum. Okay. Do I have any minimums on here?
Yes.
Yes. And where is it at?
That's the one.
At the origin. This is my minimum. This is my relative minimum. And it's going to be a very relative minimum because the function is going to keep going what? On forever, right? So it's not my absolute minimum. It's my relative minimum to the rule of being a local minimum, where I'm decreasing then increasing. Do you feel like from a graph, you can look and highlight where relative max and mins are located? Yes, doable? All right, cool. Now we have this guy here. The local maximum and minimum are called your local extrema. Okay, you don't say how many maximums do you have or how many minimums do you have. Okay, they're collectively called your extrema. Okay, your local extrema of the function. Okay, if it's one extremum, I can't say that word. I just say local. Local max, local min, and call it a day. But wanted you to know that. And here we go. On the graph at the right, I didn't give you colors until you needed colors, but I'm going to highlight for you in green where I'm increasing. So in green, I'm increasing because we read the graph from left to right. This is where I'm increasing. How would I describe that interval of increase? From where?
-1.
To -1, because X marks the spot. And I did my research and I'm right, and not the College Board program I bought. It should be parentheses. Even Khan Academy agrees with me. It should be parentheses when you're determining increasing and decreasing, because you can't contain those points. You're not saying am I equal there? You're just saying where does it happen at? Okay, so we do use parentheses when we're describing increase and decrease. Okay, all right. And I say we go with Khan Academy because Khan Academy is tied to the SAT, and that's how the SAT is going to present it. Okay, all right, all right. Moving on. Do I have another interval of increase?
Yes.
Why? Yes, we do. 2 to where? 2 to positive infinity. So negative infinity to -1 and 2 to positive infinity.
Did you put the U symbol?
Yeah. To shorthand it? Yes. All right, now we're going to highlight red. Where are we decreasing? There we -1 to what? There we go. So we decrease from -1 to +2. Okay. So that's describing the intervals. Now, when we're talking about label the local extrema as a maximum or a minimum. So when I look at this graph, do I have some extremas? All right, where are they? Oh, we're going to label it on our graph. So what do we have? There we go. We have a local max here at -1,6. It's not our absolute because notice that it goes on to forever, right? We already discussed that. Perfect. And this is a local local minimum. And again, we're calling it a local because it's not our absolute lowest, right? Because we go on to infinity. Okay, when you are writing out your local max and min, if a problem says label your local or what is your local max and min, it's asking for y value only. Okay, exactly. So we would say our max is 6 at x equals what? -1. And our min is at x equals 2. Okay, x tells us where, y tells us what. Okay, x tells us where, y tells us what. Where is your max or min? What is your max or min is going to be your y. Okay, how do you feel about identify max and min? Easy peasy? Yes, I feel like part 1 should be easy. What time do we get out? We get out in 4 minutes. So the next part is doing this with the calculator. And I don't know if we can do it in 4 minutes. I mean, I can show you, it really doesn't take that long. But sometimes you guys get a little, oh no, calculator. And second guess yourself. So I'm gonna model it, but I'm gonna redo it again on Tuesday. Does that make sense? Okay. So when I go to the calculator, I'm going to clear my calculator just because there's a bunch of junk on it. After you clear your calculator, we're going to switch our mode because for AP testing, we want to round to the nearest 3 decimal places. And if I have the ability to let the calculator round for me, guess what we're going to do? Let it round for us. So where it says float, we're going to switch that to 3. And then from here on out, as I work this problem, the calculator is going to do my rounding. Does that make sense? Okay. So then you would graph and analyze. So we would graph -2x to the 5th. Yes. In the file cabinet.
Is it the second time?
Yep.
Yes.
Okay. So now I have my equation in. I'm going to go to graph and let the graph do some thinking. Oh no, it's taking forever because my graph is old. Sorry. The reason why I showed this example is because notice here, I clearly see that there's a minimum, but there's also a maximum because how is it going to go up and not come back down, right? So this is an example where we don't freak out. We just adjust our zoom. We can zoom out. Yeah, we got to go to second trace. But sometimes zooming messes it up. You go second trace, and that's where it's at. Yeah. And then it'll pop up, and then we'll find it, and we're going to identify it from there. Not bad. All right, so we will pick up to Tuesday.